Hello everyone, we are back with another workshop. Welcome to IBC 2.0 Continuum's second workshop from IBC Media. Just so you know, IBC 2.0 is the second edition of a massive 5-year agenda enabling the largest blockchain ecosystem initiative in India. Today, we are going to have another interesting session on how to develop blockchains that evolve using Polkadot's Substrate tools. Polkadot, as you all must be aware, is our headline sponsor for IBC 2.0 Continuum. This workshop is an opportunity to pick up some unique learnings on one of the most emerging tech spaces led by our eminent blockchain expert, Radhakrishna. Today, we will be diving into Substrate. Substrate framework lets you develop customizable and upgradable blockchains that are ready to become parachains on the Polkadot network. In this workshop, we will explore how to leverage Substrate's tools and develop and design domain-specific blockchain applications. This workshop features hands-on activities that can help you get started with building meaningful use cases for Web3. I hope all these terms sound familiar to you by now after last week's insightful session, Polkadot 101 workshop by IBC Media. If you were not able to join us last week, we got you covered as we have Mr. Radhakrishna Dasari with us today. Radhakrishna is a technical educator at the Web3 Foundation, which nurtures technologies and applications in the field of decentralized web software protocols. Prior to joining, he was a faculty member at the Department of Computer Science at the University of Vermont and has a MS and PhD in computer science from the University at Buffalo. The State University of New York, Radhakrishna is excited to put his skills to use for educating professionals and the general public about the vision of Web3 and its technology stack. So let's dive right in. Over to you now, Radhakrishna.
Thank you. Thank you very much. Can someone confirm if you're able to see my screen?
Yes, I can see your screen.
Perfect. Yeah, I see we have, about like 26 participants. I think it's the right size for the workshop. I see more people joining in. So I posted a couple of links in the chat. So feel free and sort of set up the Substrate playground. All you need is a GitHub account. So have it ready. In the middle, we're going to have some hands-on experience with like building blockchains, adding custom logic to blockchains. Okay, so let's get started. So here is the really interesting thing about like Substrate. You can build customizable blockchains. So that is the whole use case of Polkadot. So every individual blockchain on Polkadot called parachain can have its own logic. And Substrate is the framework that lets you build those blockchains. And also, if you've attended the previous session, I've talked about the forkless upgrades that every parachain enjoys in Polkadot ecosystem. So basically, your blockchains can evolve over time. So you can keep adding new features and then just deploy them to your parachain. So today you'll see a brief glimpse of how all of it is done. All right. So again, I'm going to introduce what Substrate is for those of you who are attending for the first time, in IBC Hack series. So let's start with what Substrate actually is. It's a modular, flexible, and extensible framework. Meaning, so if you go to the GitHub repo of Substrate and then look at all the folders there and all the organization in there, you see that everything is modular. And it's flexible, meaning it's not set in stone. So you can go to every single module in there and then sort of modify the code as you need. And you can eliminate few modules, you can use a few modules, or you can use all of the modules, etc. And also it's extensible, meaning not only you can change something within those modules, you can create like your own modules. So Substrate is a blockchain building framework that is very, very modular. Now, why would you want to use Substrate? Being a blockchain developer, just getting started, it can be overwhelming. So you would need somewhere to start, right? So there's too much going on with blockchains. There's networking layer, there's a consensus layer, and then there is application layer. So most likely, if you're somebody who's trying to create blockchain applications, you'll be focusing on the application layer, right? So you don't want to deal with how the blockchain nodes connect to each other, or how they talk to each other, or how the blockchain comes to consensus. So all of that is pre-packaged in Substrate. So you'll be using the battle-tested libraries. So if you go to Polkadot or Kusama or any sort of Substrate chain, all of those are like blockchains that are adding a block every 6 or 12 seconds. So things are working in production. So you'll be using the same level of production ready libraries right from the beginning and focus just on the application development aspect. Yeah, so here's where I'll introduce some terminology related to Substrate. So if you decide to build on Substrate, so you'll come across Frame. So Frame is the framework for runtime, aggregation of modularized entities. Long story short, these are the libraries that are going to you're going to use like Lego blocks. You're going to just import them. So they are already there in the Substrate repository, like the GitHub repository. So you're just going to bring them into your blockchain application logic, use them, tweak some parameters if needed, and make them work for you. So the terminology, I'd like to introduce that to you here. So they're called like palettes. So Substrate palettes are from Frame. So these are, so palettes are where like you can write your application logic and then sort of deploy. So yeah, I've shown this before in the previous presentation, but that's fine. So I'm gonna repeat myself here. So Substrate comes with like a template node. So this is usually the starting point for any sort of developer who's trying to enter Substrate ecosystem. If they just want to try out things, they're going to start with the Substrate template node. So today's workshop, like you'll be seeing that live as well. So Substrate template node is a repository, GitHub repository, so you can download, clone, and then just get started building a blockchain. So and then so this is the development ease graph right there. So this is very easy. And then comes like Substrate Frame. So you can use like existing modules that I've already mentioned, or like you can create your own modules. That requires some level of like understanding of Substrate framework. It also requires you to have some level of Rust experience, that lets you like write code. So this is where so your Rust programming language and the knowledge about like Substrate and the way things are organized, that's going to help here. And Substrate core is like, it gives you a lot of technical freedom in the sense you can change the core primitives of the blockchain itself. Like you need not use any of the libraries given there. So you can actually mess with something at a very core level. This is mainly for like blockchain engineers. Like for instance, I mentioned Parity Technologies based in Berlin. So they are the developers of Substrate and like Polkadot. So they are like very well versed with Substrate core libraries. You could also like so Substrate sort of gives you that level of technical freedom. All of this code is open source. Everything is open, so you're free to even modify stuff at the core level. All right. Yeah, so this is the example visualization I just show to just show you like how easy it is to sort of include these palettes into your runtime. So runtime is the blockchain's application logic basically. So runtime, any sort of code that you put in runtime is executed as part of like the blockchain natively. And so you can choose like what you should have in the runtime. So for instance, if I import like balances palette, right from the beginning, I have the blockchain has the ability for account creation, setting like a balance, setting the units, the tokens, transfers, and so on and so forth. So you have everything right from the beginning, so you don't have to write any code for balance transfers, etc. Okay, so and then similarly you can have like a staking one. So Babe is and Aura are sort of block production mechanisms. So they are hard coded as well. So all you have to do is define, I'll show you later, like authorities, like who can produce blocks, and then you use this logic for like, block production, etc. So it's like that. So if you're someone already familiar with like Solidity, and then you're very familiar with how EVM works. So there are, palettes out there, so which support sort of EVM execution. So you can port like the Solidity code to like, Substrate based chains as well. So plenty of libraries out there for you to drag and drop into your application logic. But again, it's not very straightforward. If you have to have some knowledge of how Substrate organizes things, as well as some knowledge of Rust programming. So briefly, I mean, in today's workshop, so we'll keep it like interactive, so you can keep asking questions. There'll be plenty of time in the middle when things are compiling, when we can sort of, interact with each other. So we're going to take a look at the anatomy of a Substrate node. So what happens when you download, the Substrate template node and sort of run it, what happens behind the scenes. So we're going to have that. And yeah, Substrate template node, and then walkthrough of a Substrate palette. So I'm going to try to like keep the time in mind. Yeah, we're doing fine. And sort of go over a Substrate palette, and then show you what it takes to write your own Substrate palette and sort of execute it. And finally, innovating with Frame. So that's the thing. You already have plenty of libraries that are out there that you can use at your disposal. And sort of how do you connect all of them together, write your own things, and innovate with your own blockchain use case. So I see a question there. Yeah, I shared the PPT, I think. So for those of you who attended the session early, could you just share the presentation in the chat? Yeah. So also like type the question out to everybody, not just me, so others can sort of help you. All right. Yeah, so here is the anatomy of Substrate node. So basically at the bottom right here, so you have lib peer-to-peer protocol. So this is the networking stack. So lib peer-to-peer is like an open implementation. So if you're familiar with like IPFS, the way you have like the distributed like file storage thing. So the developers of IPFS are the ones who develop lib peer-to-peer as well. So when parity engineers were creating like Substrate and a blockchain node, they sort of felt they should reuse the lib peer-to-peer library. So this gives you networking stack right out of the shelf. So what happens is when you're spinning up blockchain nodes in the same network, they can connect with each other, out of the shelf. Like you spin them up, and then they all talk to each other in a decentralized way. And then so there is a way of like node discovery that can be done with lib peer-to-peer. So that sort of bootstraps your blockchain network in general. So that is taken care by lib peer-to-peer. And then the core logic, the core logic of the blockchain, it's all coded and deployed as a WebAssembly blob. So WASM is the next frontier in like blockchain technology. So you see many blockchains trying to adopt to WASM, because WASM is cross-platform, so it can run on browsers. So there are also plans like Ethereum to sort of have this WASM kind of runtime, but mainly Substrate and Polkadot. So by default, like everything, the code in the runtime, so it's based on WebAssembly. So the beauty of WebAssembly is that you just need not only like code everything in Rust. So there are other programming languages too, which can like give out like a WASM blob. Okay, so that is the one that's going to go into like the blockchain's runtime and then sort of execute stuff for you. And for consensus, like Grandpa is like a algorithm for consensus. I mean, for Bitcoin, you have like proof of work. And that's like a probabilistic finality, right? So you keep adding blocks, and then as the depth of that block increases, So you can be confident that that block or transaction in that block is sort of final. So similar to that, like Polkadot has like proof of stake, but proof of stake is just going to decide like who will create those blocks. So the grandpa finality gadget is the one that tells like everyone in the world that a particular transaction is final. So you don't have to really understand the how it works, or I mean, it's a good read. It's in a paper, but ultimately know that So on Polkadot, if you see on Polkadot.js, every 6 seconds, like a new block gets produced, and every 20 seconds, like that block gets sort of finalized. So grandpa algorithm, so that's packaged right along with the substrate node. So even the finality is shipped with the node. So I see a question. Let's see. Okay. All right. So yeah, so if you want to like get started, so I already shared the playground address. Sorry, let me share that again. So if you want to follow everyone in the meeting. Yeah, so if you like to follow the hands-on activity that I'm going to show today, feel free to like set yourself up on Substrate Playground. If you're tech savvy, and then so how to do stuff with like command line and stuff like that, and GitHub. So feel free to like download the Substrate template node from the GitHub repository, set it up on your computer. The instructions for setup are pretty straightforward for like Macs and like Linux machines. For Windows, it's a little difficult, so that's why I have the Substrate Playground shared. So irrespective of which computer you're on, you have a browser with internet connection, so you can check out like Substrate and its capabilities on the Substrate Playground. All right, so yeah, so here, if you I mean, shortly I'll show how the code is organized inside this Substrate template node, but you can explore. You'll see that everything is like very modular. So there is a folder called as palettes. In that, you can create like your own palette if you want. So there is a runtime folder, and inside the runtime folder, there is a way to like import all these palettes into your code. Yeah, so I have the Substrate Playground link here. So I hope some of you at least like set it up. I'm going to now like demonstrate a short tutorial. So in this tutorial, what we're going to do is, so the blockchain accounts that you see, so you create a public private key pair. So you can give it some sort of name, but most often that name is just local. So it's not sitting on the blockchain. It is the name that you have given for that account like locally. So if a blockchain has to store some kind of information regarding your account and preserve it for every single block in the future, so that's going to involve some cost, right? So every single validator, every single node is sort of keeping track of that information in the runtime. So basically on Polkadot, so if you want to create an identity on chain, like if you want to put your name on chain, then it is required that you put some deposit. So the deposit is going to ensure like people don't spam the network with like a lot of names. So you put a deposit, you give a name to an account, and then the blockchain network sort of accepts it, and then whoever opens your account in the Explorer will see that sort of name. So this is the functionality. So I gave you the backdrop of why we would need it, and let's see like how to add it to a Substrate template node. Okay, so without further ado, let me do this and then go to Substrate Playground. Okay, so I just want to show you, so right after you open Substrate Playground and open like the Substrate node template, you will already see that a blockchain is started and it's running. So as you can see, right now the blockchain has like 254 blocks, and this is all the code. Yeah, so the workspace, I'll go over this shortly, but yeah, so you have all these folders, and then the blockchain is already up and running. If you just want to like visualize like what's happening in this blockchain, instead of going to the command prompt, you can go to Playground and open Polkadot.js apps. So what I'm doing is basically, so Polkadot.js is like the infrastructure like everybody in the Substrate and Polkadot ecosystem can use. So they can actually use this to visualize like what's happening within the chain. So let's see. So whatever was shown on the command prompt is being shown here. So I have like 262 blocks. Every 6 seconds, a block is being created. So what I'm going to do is, so in the developer tab, so if you go to like extrinsics, so extrinsics are the calls that you can make to the blockchain. So these are the calls that you can, so these are the functions that you can invoke in the blockchain. And here you see all these palettes. Okay, so I have balances, I have grandpa, pseudo, system, and there's like a template module. So this is like a template where you can add your own code and so on and so forth. So these are the modules for which like you can make calls. So what we're going to do, we'll add like a nicknames palette here. So Substrate already has that. So let me show the Substrate repo. So if I go to Substrate, in here, like I have Frame. So like we talked about Frame earlier, Frame has all these palettes that you can use right off the shelf. So you have, so bags list was recently added for like staking if you're following the Polkadot space. So you have a bunch of palettes here. And then what we are going to add is this Nix palette. So this Nix palette is going to add nicknames to the accounts on blockchain. So every palette has like a source code. And for those of you who are familiar with like Rust, so cargo toml file defines like the dependencies. Okay, so Nix palette, not everything is coded from scratch. You would want to like import some of the pre-existing libraries. So to put everything into the context, like you have a cargo toml file for Rust. This is going to fetch all the dependencies for you. And then inside the source folder, you have the lib.rs file. It's a Rust file. So in here, you're going to see the code for Nix palette. And once again, I'm highlighting this. This is not written by you, or you won't make any changes to it. So this is already out there in the Substrate repo. All we are going to do is import it into our runtime. So let's see how to do it. So for that, I would share the, so this tutorial link with you. So feel free to follow it through the link or how I'm walking you through. So this gives you like some kind of like context as to what we're doing. So we'll be able to set a name for an account. We should be able to like clear that name and get our deposit back. You can also like kill names. So this is mainly for people who sort of have malicious intents. Like if you just want to, someone claims that they're Bill Gates or something, so you should be able to invoke this function and then sort of kill that on whatever. So these are few functions that are available in this palette. So the tutorial objectives I mentioned. So you'll have to bring this palette into the runtime and make it work. So let's see. So the first thing is, let me show you the structure of the. All right, so go to Substrate. So this is the typical Substrate template node. So if I go to node, so you're not going to modify anything, but I'll just show you like where things are sort of written. I'll also like stop this blockchain. Okay, so now the blockchain is stopped. So chain spec. So chain spec is the specification of your chain. So right from the beginning, the first block, which is called the Genesis block, fetches details from this chain spec. And then the blockchain keeps like, building on top of this previous block, and every call that you make to the blockchain is going to change the state of that blockchain, right? So the initial block, the block number 1, is created based on whatever you give in this chain spec. So in this chain spec, like you have a bunch of things. But yeah, so you can already see that there are few accounts, by default, like Alice, Bob, are few authorities or whatever. They have like a bunch of, so they have like a public key, they have a private key. All of this is known. So it's just like bootstrapping the blockchain network with these default accounts that anybody has access to once you start the blockchain. Fine. So and then you have like CLI arguments, or so you have like RPC calls. If you plan to implement them, you put it there, and so on and so forth. So let's not waste our time right there. So I mentioned to you, palettes is where you're going to add new palettes. Like if you're trying to create a new functionality, so if you're going to create new functionality or all by yourself, you're going to like sort of add that palette here. So if time permits, we're going to do that as well today. But for now, our focus is on the blockchain runtime. So blockchain runtime is the core logic of this blockchain. So let me go in there and then open the cargo toml file. So I mentioned to you earlier, so cargo toml file is something that holds all the dependencies, all the libraries that we're sort of importing for like runtime. So in here, you clearly see, so all these dependencies. So there's a palette balances, so this palette is in the Substrate library. So if I go to frame, and then we have like balances here. Okay, so just by adding this single line of code, so saying palette balances, version so-and-so, and this and so-and-so. So you're basically importing the entire library. Okay. So similarly, you have all the other palettes that you have imported into Substrate template node. All of this is the code that comes with Substrate template node. So here, what we are going to do is, so here you don't see the next palette being imported. So let me add that line of code. I'll fetch that from here. Okay, so let me copy this code, and then go to Substrate playground somewhere here. It doesn't matter where you put it in this space, but yeah. So all I did was I added palette next. So there's a version, and then the repo from where I want to get it, and just make sure this branch tag sort of matches with the others. So if you put like a different number here, maybe there's like a compatibility issue. So just ensure that it matches with the version like there. Cool. And then if you see, the default features have been set to false. I don't want to discuss it here. It's a little out of scope. But again, this has to do with the WASM runtime build. Okay, so we just want to disable the default features here and sort of enable them later on, like here. So we're going to so then let's look at the next step. So we have that, and then so here it's saying add palette next std features to the list of features to enable when compiling the runtime. So feel free to read through the context as to why we are doing it. But all I'm going to do is add this one line of code to somewhere here. Okay, so just below palette balances. So simple. So I've just imported the palette next, giving that dependency thing right there and enabling the standard features right here. So here, I'm just going to save it. So that's it. So let's see if palette next is sort of imported properly. So to do that, let's go to here, and then let's see if this node template like runtime is working properly. So cargo is like, it's sort of like a package manager dependency handler or whatever. So for Rust, it's going to just tell you if things are going to work well. So I'm just going to check like what's going on here. So I'll go and then copy there. Done. So now Rust will like faithfully check, whether the dependencies that we just added, whether they're compatible with the runtime or not. So meanwhile, so I'm going to go back to what I've shown like earlier. Yeah, so let's go to like runtime library. Okay, so this is just the dependencies file. So let's look at the core like logic that is implemented within the runtime. All right, so I'm going to zoom this one a little bit. Can someone confirm if they're able to read the text on the browser? Because I just don't want to assume that it's being streamed well. Can you see like the text or read the text on my screen?
Yes, Radha, we can.
Perfect. So let's see what we have here. So let's see. So this is the palette template, and then so you have like a bunch of things like ready in here. So I just want to show where. Yeah. So if you're like tired of a block being produced like every 6 seconds, rather for testing, if you just want like 1 second, so you can modify it here. So that's how customizable like your blockchain is. So basically I'm just going to leave it like that, or I'll just put like 1,000. So the block time of like 6 seconds was chosen by Polkadot, just to ensure the the block production. So the core logic is sort of executed for like 2 or 3 seconds. In that 3 seconds, so the other time is reserved for like block transmission and so on and so forth. But anyway, so for development purpose, if you just want to see how your blockchain is sort of building, so you can change that parameter as well. So feel free to do so. And then let's see how we are doing with the, I'm just sort of passing time here. Yeah. So we'll let it sort of do its work, and then I'm going to go over this runtime and show you where exactly we'll sort of make changes. So here, what happens is we are already importing the palette, right? So that palette sort of gives you an interface. So you're capable of like modifying the parameters in there. For instance, we're talking about the nicknames palette, right? So you can set, okay, so the minimum number of characters the chain should accept is 8. So if the user enters like a nickname with like 7 characters, the chain should reject it, right? So all of those things you can sort of mention them here. So just the way I was able to like modify the block time itself, so I'm able to like change those preset like values as well. So let's do that. Let's go back to this thing. And this part of the tutorial, it's showing you the balances palette. Okay, so balances palette is what lets you like transfer balances between the accounts. It's showing like a bunch of types that the balances palette uses, and so on and so forth. But yeah, so that is only for information purpose. But here we're going to like use the next palette configuration, right? So what we're going to do is, yeah, so let me sort of import. So I'm copying this code. Okay, so implement. So like I said, palette next is already present in Substrate repo. So here we're implementing that palette, giving it some like values. So here the nickname, the min length is 8, the max length is 32. So we're going to give those values in the runtime code right here. I'm going to go back here, and then so yeah, so you can see like palette balances here with like its values. So I'm going to copy that code right below, right there. Okay, so now I'm sort of implementing the next palette, which I've imported using the dependency that I included in the cargo terminal file. So here I included the next palette, so it imported that. Now what I'm going to do is I'm going to implement the interface that I have. So here there is a reservation fee. So you can set it to whatever value that you'd like. So let's make it like probably 500. And then, so I'm going to reduce the minimum characters here to 6. And then maximum length 32 is fine, or whatever. Yeah, so so we're not done yet. So we implemented this. Now we have to add this to runtime, right? So we're not done yet. There's one more step. So here we set all the values. Now let's add the palette to runtime. So for that, search for like construct runtime macro. So construct runtime is what puts together all these palettes into like a single executable, and then sort of updates like the blockchain, right? So what we're going to do is we'll add this one line to the construct runtime block right there. Let's see where it is. It's right here. Yeah, construct runtime. So construct runtime. So in here, I'm just going to add that line of code. And that's it. So that's how easy it is for you to like add a palette into, a Substrate template node. So if you don't believe me, then let's see where we are with compiling. Yeah. So what this just previously, what did we do? So we just checked by using cargo that the next palette is successfully sort of imported. Now in the runtime code, let me save this. Yeah, in the runtime source code, like we implemented, a few parameters of next palette, and then we added it to the, runtime. Now what I'm going to do is I'll go back and yeah, so just ensure like everything is working. So instead of this, I'll just try to like build this like right away. Playground. All right, so now what happened is I created like what I wanted. So I needed like a blockchain with like this nicknames palette. So what this is going to do is it's going to compile the whole Substrate template now by including that nicknames palette. So I'll let it do its work. And meanwhile, so we'll go back to presentation. Even you, when you do that, you'll sort of see it compiling as well. So let's come back to this again, and I'm going to show you like how the new nicknames palette that we added is working on chain. Right. So let's move to Substrate presentation. So the next thing I wanted to show you was this. Okay, so far I just showed you right out of the bat, like how to add like a palette, but what exactly is a palette? Like what code do you have in it? So as you can see, whenever you're trying to write a new palette, you're going to perform the imports and dependencies, and then you're going to declare like the palette type. Okay, so what kind of traits and methods are going to be there in this particular palette. Yeah, so and then you have like the runtime configuration trait. Again, like this is very important. So which is exactly like what we used in the runtime file previously. And then the runtime storage, like all the storage items this particular palette might sort of use. And this is also very important when, as a blockchain developer, your task is to minimize the storage that is required by your code, so by your palette. So it's very important that you use the storage like very efficiently. So the runtime events, like what events should be triggered when something sort of happens in the blockchain that is being tracked by this palette. So there are some hooks that you can include, as well as the extrinsics. What are the calls that you can make to this particular palette? So I'm gonna share this link as well. So this is an exercise for you after, so after you finish this workshop, today, and you want to explore like further on how to like write your own palette. So for instance, you can see here like that, so you could actually create a palette to sort of create kitties, which look like these crypto kitties. You can create them, you can sort of put a price on them, you can sort of sell them on chain. So all of that is mentioned in here. Like I mentioned, in the interest of time, so I'm going to skip this till the end. So if we have time, I'm going to show a demo of this as well. But yeah, so feel free. I just posted the link there. So that's something you would want to like explore and follow through if you're interested in developing, on Substrate. So let's go back to Playground. Yeah, we're still a long way through. So this is one thing with like Rust and sort of like Substrate in general. So it has like too many dependencies there, so it takes a while to compile from scratch. So yeah, I really want to show you some demos. So let me do this for you. Let's go here. So whatever code I've shown like earlier about Substrate kitties, I have it here on my computer. So let me sort of show you exactly how it works. Okay, so I just started the blockchain using the same command that I had there. And then, so I have a blockchain, and then it's creating like blocks. So I'm going to use Polkadot.js to connect to that development. So I'm just going to refresh this. So here I'm using the local node. Okay, so this is a node that I created on my computer. So yep, so let's go to the Network Explorer. So on my computer, I just created this blockchain node, and then I started it with block number 7. So block number 7, that's what I'm seeing here. And like I mentioned, the extrinsics, the calls that you can make to the network, so they're available here. And then the Substrate kitties, like if you follow this entire, so I shared that link with you. So if you follow that tutorial, you should be able to see Substrate kitties palette, being added to the runtime of the blockchain. So you'll be able to access that through the UI this way. So in here, like you have like a bunch of things that you can do. So let me create a kitty and see like what happens. Okay, so I'll submit this transaction. Like I mentioned earlier, I showed you like chain spec in the Substrate template node. So Alice is a default account that anybody can use. Okay, so right now I'm just going to sign in on behalf of like Alice and sort of create. And Alice has like enough balance right to begin with, and it looks like the Substrate kitties create kitty went through. So if you want to explore like what happened in the network, go to the Network Explorer. It shows you like all the events. Okay, so in the palette there were like a bunch of events, right? So once somebody calls a function in the palette, it creates those events, and that event was to create a kitty. So that kitty has a unique identifier right here, and then it exists there. So now I could also, so you can build like a front end for this, like that are out of the scope of that tutorial. But again, like with this hash, you can create the appearance of the kitty, how it looks like, what color it looks like, what pattern it should be shown. So all of that can be done. Very interesting UI, but this is basically the backend, like the runtime itself. So let me show you more things here. Let's go to extrinsics, and then let's go to Substrate kitties. Okay, so there is also a set price. So for this, so previously I've shown like an ID, so you can copy that here, set the price for it, and then sign and submit the transaction, and then that will be sort of stored on chain. So you can build like the applications like this using like Substrate. yeah, so to be able to do this, like, let me show like what I did. Okay, so I have, okay, so what I did was in palettes, the lib.rs file. Okay, so this is where, so I've written like everything. Okay, so in palettes, initially this code will be just like a template code. So you can sort of extend it the way you want. So here I've defined like all the storage items that I would need. So I have all the palette events, like, generate deposit, the error that should be thrown or whatever, and so on and so forth. So feel free to like explore this resource and then see like how to create like your own palette. Let's go back to our browser and then the playground. See how far we are in terms of like compiling. Yeah, now I'm sort of open to questions because again, I mentioned, so this is going to take a while. So far, like, what do you think of Substrate in general, using like the existing code, sort of compiling it and then seeing whether it sort of works or not? Okay, we'll give it more time. So what I'm going to do is I'll continue with the presentation I have here and then take it like at the end. All right, so. Okay, so let's go on with the presentation and get back to the Substrate playground like later on. Let's see like what you can do with Frame, right? So initially I told there are primitives, like as a developer you have an option to sort of modify even them. So how the runtime should be, what the RPC calls should be, and like the core aspect of like Substrate. So SP stands for Substrate primitive. Okay, SC stands for Substrate client. So this has to do with the node of the Substrate. And then like every Frame library, as the name suggests, it's named with like Frame, and then Frame system, Frame support, and so on and so forth. And then finally come the palettes. So these are the application level modules that are present in Substrate that you can either import or write on your own. So again, just refreshing like what I've taught like earlier. So Substrate gives you like the technical freedom to modify things here. But as a developer, if you want to get started, you'll always get started with Substrate template node. So a brief overview of like Polkadot again. So we have Polkadot, which is like a heterogeneous multi-chain, meaning every single blockchain that you see has its own state transition logic. So for instance, today, like I've shown you two applications, right? So one chain lets you like add nicknames to it. The other chain lets you create like Substrate kitties tutorial. Okay, so two of them are developed on like different machines. Both of them have like different state transition logic, and both of them can become like parachains on Polkadot and run like independent blockchains. So that's how like Polkadot does it. Like it gives security and interoperability for those two blockchains. So if they were to talk to each other, Polkadot will sort of support that. If they want like security, meaning that blockchain has to be protected, intact, so Polkadot offers that as well. So I've covered this network architecture previously. So basically the nodes that are sort of producing these blocks, so are going to be like validators. So this chain is not a parachain on Polkadot yet. So it's like a blockchain running on its own. So we have these validators that are adding blocks on top of this Substrate-based chain. So once it becomes a parachain on Polkadot, then you need not have validators of your own. So you'll basically be assigned with like validators on Polkadot network, and you only have nodes that sort of collect all the transactions that happen on the network and sort of send it to like Polkadot network for validation. So again, like if you go to Parity Tech GitHub repo and look at like Polkadot and Substrate code, there's a lot of overlap of Polkadot code with Substrate. So the idea is to have like Substrate being like a blockchain building framework, and Polkadot was built on top of it. So both of these code bases are very similar. So if you develop a blockchain with Substrate and then try to make it compatible with Polkadot, it's going to be like very easy. So a couple of things I want to mention about Polkadot in general. Again, like Substrate and Polkadot go together. So whatever blockchain you build using Substrate can become a parachain on Polkadot, and it can enjoy like all these features. So my favorite feature is like self upgrades. So the way it works is, so let's say I created this kitties blockchain, right? So I thought like these functions would be enough, and then I deployed it as a blockchain. But think of it like if you are like a Bitcoin network, if you want to make some change to your application, change some call logic in the blockchain, then you have to face a lot of resistance with the community, right? So Bitcoin network has never changed much over the years. Like you like to keep it like constant, but the other application-based blockchains are not like that. They would want to upgrade as they sort of progress. So Substrate by default gives you that option to deploy those upgrades. So you can start your blockchain like this, and then you can change your product later on like that. And the way it works is by design. So blockchain and blockchains like Bitcoin and Ethereum, so if you make an upgrade somewhere here and the community is sort of split, then there might be few nodes that doesn't accept that upgrade and run the old software and create this chain. And there might be few nodes that accept the upgrade and then sort of create this chain. So what happened here is a hard fork. So the hard fork is like a big problem for legacy blockchains in general. So that's why like Substrate has this internal design where the state transition logic that runtime that we are compiling, that is actually part of the block. So if you deploy an upgrade, via governance or via sudo, or you're the sole authority of the blockchain, so you can deploy the upgrade. So that upgrade, is part of like a call that you make. So there is actually a function called as set code. So in set code, you're going to change the parameters. So let's say the nicknames palette, which I'm going to show you shortly, you want to update the length from 3 to 8. So you can't stop your blockchain, or you can't deploy a new node client for everybody with that tiny change, right? So what you do is you make a call to that particular runtime like palette, and it sort of sets that code here. And from the next block, the validator who is going to create that block is going to run that code over the transactions. So it is very seamless way of upgrade because the code itself is part of the blockchain. The validators need not like download the code, from like a GitHub repository or from Twitter thread or whatever. So you have the code being deployed, on the blockchain itself. And that's the clever way of like forkless upgrades. But again, yeah, so on a network like Polkadot, this sort of upgrade is sort of administered using like governance. So governance is the one that takes care of upgrades. People can fight over this upgrade on the governance channel or on chain, like there's a governance proposal. So there people can add their opinions and fight it over, but ultimately it ends up with a result. Either the chain is upgraded or it's not upgraded. And that part, the technological solution for that is very seamless. Yeah, so even that is part of like a tutorial. Again, like if the tutorials that you saw, if they are like intuitive, try out like other tutorials we have as well on Substrate docs. And one of them is upgrading a running network. Okay, so I already showed like a blockchain network running on my computer just now. So it's like adding blocks on top of it. So without stopping it, how do I upgrade the code inside? Okay, so that's what this tutorial is going to show you, and that is the power like all the substrate based chains sort of enjoy. So now the title of today's talk should make sense to you. Okay, developing customizable blockchains that can evolve, right? So you by default, like you can use like all the palettes that are out there. You can create a blockchain, write your own palette and create a blockchain, and you're able to like evolve that blockchain over time based on the needs and necessities. So you can deploy like new functions or new code to your blockchain and sort of make it work. So just to give you an overview, again, all of this is not built behind like closed doors. There are plenty of projects that are out there which have used Substrate to build their blockchains. So with plenty of use cases. So I would suggest that you look into those projects and their repositories to understand, how they implemented that specific use case using like Substrate. Yeah, so again, like Polka.js, the UI that we used earlier to check like the Substrate template node, it can also be used to check like other Substrate-based chains like Polkadot. So let me show that live to you. All right, so we're almost there. So 10 more libraries to build. So I'm going to leave this session only after like showing Nick's palette demo live. But anyway, so let me open Polka.js again. So here I'm just going to show you like the power of like this UI, and then how many developers sort of use it. So Polkadot and its parachains. Okay, so let me switch to Polkadot. Okay, so Polkadot has over like 11 million blocks, and these are the events that are sort of happening on chain. And if you want to see like the extrinsics that the Polkadot usually supports, there are plenty of palettes in Polkadot out there. Okay, so for those of you who are aware, so we have democracy on Polkadot. Okay, so if I said this, so there are a bunch of things that you can do with that. And democracy is sort of a palette, so again, other blockchains can use it as well. So let's look at a parachain on Polkadot. So I'm just going to click on this one right there. And then even this one, okay, extrinsics. And then, okay, so it has its own like extrinsics. See, aggregated DEX or Akala Oracle or whatever. So these are like palettes that particular blockchain has developed and sort of integrated on their blockchain. So you're free to like explore these. Or we have like Kusama, which is like Polkadot's canary network. So all the palettes that you see here are very similar to like Polkadot. And then finally, so there are test nets as well. So if you want to test out like few features on Polkadot, so you have Westend, whose code base is very similar to Polkadot. So you can do that, or you can switch to like local node. So local node is something that is running here. So let's see the block number here, 167. Okay, so let me switch to this blockchain network that is actually running on my computer. So let's go to Network Explorer. So you see, so 168 blocks that are out there. So the Polkadot.js UI is very flexible, and it goes in hand with like Substrate template node. So you should be able to like do all this stuff. Okay, so you can query the chain state. So let's see Substrate kitties. How many kitties are there? So I created only one previously while showing this demo. So you're able to like query the chain as well using this. Like chain state you can query. Extrinsics are the calls that you make to the chain. So you can also make like RPC calls to the chain and sort of get like the chain state that way, and yeah, so on and so forth. So let's see. Oh man, so we have like two more here. So instead of me like rambling something right now, I'm open for questions. So if someone is curious about some aspect of like Substrate development or Polkadot, now is the time for you to ask. So before these two things compile, and I'm happy to like answer. Anyone with any questions? Yeah, that's the thing with like live demos, that they never sort of go according to the plan. Okay, so we have like one final library there that's compiling, and let's hope it finishes in time. Yeah, so like I mentioned, after this workshop, try to like do this Substrate Kitties workshop. So it starts with like setup, how to set up like your project. If you're well versed with like Rust already, so feel free to like follow the instructions and do the work by yourself. So the way it works is it gives you like all the context that is required, all the knowledge that is required about like the Rust and the storage items that you're going to use. And then it starts with actually doing stuff. So here you have like the code, and then you have the solution as well. Okay, so that way you can verify whether you did something correct or not. So if you're impatient and if you just want to like test out things from the beginning, yeah, so we have the solution right here. Yeah, this one. So this has like the entire code for the entire Substrate Kitties palette. So you can just copy this, and then I already showed you like how to add the palette. Okay, so you're going to add it to the runtime, and then add it to the construct runtime macro as well, and then you can like launch it. So that's as simple as that. So you'll follow this tutorial, add all the code to your Substrate template node, compile it, and then run it. And from then on, you should be able to, on the front end, you should be able to like create Substrate Kitties. Let's see where we are here. Oh man, this is not just that one thing. So the organizer, IBC Media, so wherever you are, you can show yourself up, and then we can have some discussion before this sort of compiles and sort of conclude today's session.
Right. So we do have a few questions from our viewers and community here. So
okay.
Yeah.
Okay. Okay.
Yeah.
Just hold it.
Waiting, yes, I was waiting for that to compile. After the
Yes.
session. All right.
Yes.
So one of the questions is, since Rust is a newer language, what prior language is the best to understand Rust? So
yeah, so anybody who is familiar with like C or C++, find it like easy to get on board with like Rust very easily. But even then, I mentioned this already in the previous call too. The Rust textbook, like the open textbook that Rust provides on their official website, so that's good enough for you to get started. So it's always better to have some programming language experience, be it Python or C++ or Java. And then if you read that Rust textbook, it actually puts you in a really good shape. So this thing actually compiled. So we're ready for concluding today's like session. So let me open the playground. Okay, so I can't do that as well. So now I have to, so I added the code. I have to like spin this blockchain node again, right? So we actually, it's not in the debug mode. So we actually had a release version of it. Okay, so now it's producing blocks, and then let's go to Polkadot.js apps. Perfect. So let's go to extrinsics, and then here I should see the Nix palette added. Okay, so Nix palette, and then here I'm going to add set name. Okay, So for the account, does it have some balance? No, it doesn't have anything. So we can't pay the transaction fee with it. Let's go to like Alice. Okay, so we have enough balance for Alice. And then for this, I'm going to put, Web3 Foundation. Okay, so this constructed the call that is required to sort of set that nickname. So let's submit this transaction. I can sign and submit this. So the blockchain sort of accepted this transaction. Okay, so you can verify that. Go to Explorer. So there is some fee that got reserved, and then if I go to accounts, and now instead of Alice, it shows like Web3 Foundation. Why? Because the blockchain itself has stored this particular nickname for that particular account. So what I'm going to do is go to extrinsics and then go to Nix and then sort of clear name. Okay, for Web3 Foundation. Let's see what happens. Okay, so now the account got back its like reserved deposit, and now the blockchain no longer keeps track of the nickname of that particular account. But yeah, so feel free, like every single palette here has like a bunch of calls that you can make. Go back to like Substrate repo, check like the balances palette, go to the source code, and try to see like how those particular calls are implemented. So in a decentralized world, you can't trust anyone, right? So that's why we have like decentralization. So you need not trust like Parity or other developers as well. So you can, all the code is open, so you can verify if a particular function is doing what it is supposed to do. If you see any bugs or some kind of vulnerabilities, you sort of add like a pull request to it and sort of solve it. The point being, like everything is out there in the open, and it's for you to like explore and start like building. Yeah, so with that, I'll stop the share, and then now I'll take the questions.
Thank you, Radha, for the insightful session. So I'm pretty sure our attendees have had a better and in-depth hands-on experience with Substrate and its features. So few more questions from our community we have here. So is Rust, would you call Rust an object-oriented programming language?
Yeah.
It is object. Okay, understood. So another question is like Python has its own libraries for certain set of functions, like pandas for data. So does Substrate have preset libraries for a certain set of functions? Let's say DeFi.
What do you mean, like Python?
So like addition of libraries in like for Rust and Substrate specifically. Is there a preset of library which has set of functions already ready?
Yeah. So again, like Rust has like a very active developer community. For instance, like before like moving to blockchain, like I've worked in like AI. So I was working particularly on computer vision. So there are plenty of like Python libraries that I could use. Like for instance, like OpenCV was the library that so first you learn Python, and then you sort of import like OpenCV and understand like what those functions do in that particular context. So similarly, like Rust has the same thing. So you have like core like Rust programming language, and then you call them crates. So people can build these like crates that people can import. So for instance, all the zero knowledge stuff that people use in like blockchain. So there is like an active development in Rust as well that you could sort of import and plug and play in your Rust-based applications.
Okay.
So I have a question in there. So Rust versus Solidity. So because we're talking about Rust, it makes sense to explain that here. So Solidity is like a smart contract, building language. So it is all that it can do. But Rust, it can actually build a blockchain itself, right? So the entire Substrate blockchain building framework is written in Rust. So every single application that you see, like this Zoom conferencing thing, or so their browsers, all of those can be built like using Rust. So people don't use Solidity for applications like that. So Rust is like a superset in terms of like its capabilities.
Okay. So another question is the way how Web3 is moving forward. Um, would you think it would be a necessity sort of a thing for a developer to learn languages like Rust and Solidity to stay competent in the developers market? So,
Yes, certainly, certainly. So Rust is, like I mentioned, it's not just for like blockchain or Web3. So there's a lot of demand in general for efficient production-ready code. So basically, Rust sort of eliminates, lot of areas where, other languages add like a lot of redundant code to what you do, and that brings down like performance. So if you want like efficient system levels, like code. Then Rust is your go-to language. And you can already see the pattern, not only because blockchains are very resource intensive. From the beginning, it made sense for usage of Rust, but it doesn't mean like other applications, even if they have like a lot of memory or resources, it should be very inefficient. So people are actually switching to Rust, and sort of developing applications in general, even for Web2 that you see, Rust is like becoming this popular choice of language out there. So the second question was, did that answer your question?
yeah,
And then,
pretty much. So
yeah.
yes, in order to stay relevant, you will have to.
About Solidity. Like Solidity is the language that people are using to deploy smart contracts on blockchains for now with Ethereum. But again, I should make you aware that Substrate has its own smart contract language. It's called Ink. So those smart contracts are deployed as WASM code, so WebAssembly code that I introduced earlier. So rather than having like EVM, EVM has, so it's been like widely adopted, but it's not that it's the most efficient way to, deploy smart contracts. So from ground up, like there's been a redesign with like Ink. So feel free to check that out as well. So Solidity keeps you up to date with whatever is happening now, but you'll have to like evolve with time in terms of like what you can do.
That's pretty much it. Thank you. Anything else you would like to add after concluding?
Yeah, I would say, I mean, I started with all this like a year ago, and I got till here. And the Substrate docs or the tutorials, we try to like keep them like up to date. And we are also like one of those blockchains that created I don't know how many of you use like Stack Overflow, so Stack Exchange. So we have like a dedicated Substrate. Okay, so I'm going to post this to everyone in the meeting. So check out like substrate.stackexchange.com. So if you're planning to develop on Substrate, so that is the place you'll find like the developers, the community, the answers for all the basic questions that you might have. So most of the tutorials on Substrate docs should get you started. So with whatever we covered today, feel free to explore those tutorials and then start hacking stuff, right? So this is a hackathon. So you know how to build a blockchain now. You know how to add code to it, change, customize it. So learn the required skills in terms of Rust to get things done. You don't have to like learn everything. Just learn like what is needed to get things working and submit like a successful submission for the hackathon.
All right. Okay. So makes it very clear for the coming generation of Web3 developers. Thank you so much.
Yeah.
Right.
Yeah, sure. And make sure you attend like all the sessions given by Web3 Foundation as well as Parity. So there are more coming up later on. So there's also a session on Ink, like smart contracts on Substrate. So,
Okay.
so make sure you see them as well, get a perspective, like where in terms of technology comparisons and have an idea there.
All right. Okay. So I think that sums it up, right? All right, so thank you guys for tuning in. So I would like to thank everyone for coming out today, taking part in our workshop. This is the second one. It goes without saying this workshop would not have been possible without Mr. Radhakrishna and the Polkadot team. Thank you so much for the collaborative effort. So we really had an interesting conversation with Mr. Radhakrishna today, who gave us a detailed and hands-on look into Substrate and how its programs work. We'll be coming up with more such workshops for you, so make sure you stay updated by following IBC Media on our social media channels, and you can visit our website ibc.media to know more. Thank you, and I will catch up with you again. Stay tuned.